In this video we'll be just taking a look at finishing up or trying to tidy up most of the loose ends on conic sections. We're working from the workbook here. I'll just start off here on page 86. So I'll be jumping from page to page and taking in most of the questions that haven't yet been covered up to this point. So you will have so far come across the conic sections as cutting the cone and seeing the 3D versions of cutting the cone there at the start of the chapter, and going ahead and drawing our cuts, drawing our focal spheres and so on, and finding directrix, focal spheres, points of contact, circles of contact and so on. Then you'd have gone on to eccentricity method, and you'd have done some work on ellipse, parabola and hyperbola using the eccentricity method, and then some basic tangents and so on. Just the finishing touches on some of the pages here. I'll start off here on page 86, question 2, shown are the directrix and vertex of a hyperbola. Okay, so when we're dealing with distances here, the point in the curve is 65 from the focus and 50 from the directrix. Okay, I'll just always write down eccentricity equals point focus over point directrix equals rise over run. Write that down straight away. You'll be using one, either rise over run or PF over PD, or maybe you'll be using both. But showing the directrix and vertex, a point in the curve is 65 from the focus. So we might as well find this point that they're asking us to find. 65 from the focus. And I'm sure that means, oh sorry, 65 from the focus, focus not given. Vertex given, not the focus. Okay, alright. Shown as the directrix and vertex of a hyperbola, point to the curve is 65 from the focus and 50 from the directrix. So, sorry, I thought that was the focus that was given. What are we going to do? So, a point to the focus is 65. We don't have the focus. And that same point to the directrix is 50. Which is rise over run as well. It's all the same thing. The eccentricity can be used to find the proportional relationship between a point and focus, point directrix, or the rise over run of the line of eccentricity. So 65 rise, 50 run, and I can get my line of eccentricity. So run along 50, rise by 65. Let's go here. 65 there, and that gets me a point on the line of eccentricity. As we would have seen plenty of examples before, usually when you have the focal point, you go up 45 degrees and drop straight down to the vertex. So we're just going to do that backwards. Up from the vertex and then down at 45 degrees to the focal point. And I'll draw the lattice rectum line. I'll just extend all the way up and down for now. And that lattice rectum line gives me a point there, which is the point at the end of the lattice rectum is a point where the line of eccentricity is a tangent to the curve, and it's a point on the freehand curve. And then I can also mirror that down. Take that distance and mirror it down here. The last move on this question here is just plotting some points. So I'll just take a 10 there in the center roughly. I'll take the one that we already have and I'll just put one more. Line them up to the line of eccentricity, bring them across to the lattice, and use your compass to apply a curvature from focal point up along the lattice line and drop it down onto the projection. that gives me 1, 2, 3 points. Now that's a long way to go. I'd probably like to put in one more projection from here. Mirror your points then, so put one more projection in up to the line across and rotate, because that's a long distance there. The rest would be okay for freehanding. Mirror your points down below and freehand the full curve in at the same time. Of course, you're not going to have a sharp point at the front. It's going to be a smooth curvature all the way through. That's that question. You can finish that in your own time. Next one here given is the axis of a hyperbola and its focal point F. I'm sure, yeah, point in the curve distances again, so I'll just write down eccentricity equals point focus over point directrix equals rise over run. So usually before I even start reading, I might read a couple of words just to make sure, right, is this all about eccentricity? Yes it is, write it down. A point in the curve is 50 from the focus, so point focus equals 50 along the lattice rectum. Ah, okay. And lattice. Given the eccentricity of the curve to be 1.25. Eccentricity equals 1.25, and I put that in a fraction, that's 5 over 4. Construct the portion of the hyperbola. Alright, so there's a point in the curve 50 millimeters away from the focus along the lattice rectum. The axis is given, the lattice and all ordinates are going to be perpendicular to that axis. And they have said 50, so it's going to be 50 each way. All these curves are symmetrical through the axis. So we're 50 each way on that one. So that is a point in the curve. It is the both ends of the lattice rectum that's shown there. Eccentricity is 5 over 4. And if the distance from here, I call that point P to focus, PF over PD, point focus over point directrix. If the PF is 5, the point directrix is 4, so whatever point focus here is 5 units, so point directrix is 4 units. And that's equal to PF is 50, we know that, which means that PD has to be 40. Okay, but when the maths works out that easy, it's great. If the maths did not work out like that, where it's all even numbers, then what you'd have to do is divide this up using a random line, random angle, strike off, so equal divisions of a line. What we can simply do in this case though is go point directrix 40, and that gives me the directrix line here. I extend through my axis, and I call that D1. That's 40 right there. Now, without your calculation though, where would it have come from, you know, so you'd have to show your calculation really. So point focus is 5 units, 50, and point directrix is 4 units, 40. Moving on, the line of eccentricity goes from the point where the directrix and axis hit through the point of contact here on the lattice, and the vertex is 45 degrees off the axis, so 45 there up off the axis, and then down parallel to the directrix, so perpendicular to the axis, and that gets us our point V here, vertex. And at that stage we're on to the same as before. We're taking some projections. Now, you don't have to have these measured, they don't have to be exact spacings or anything like that. You can just take any random projections if you feel like it, or you can measure them out. And project them onto the line of eccentricity. Project them onto the lattice there in green. Finally, from the focal point, open out to each point on the green line and rotate back down onto the projection, or onto the ordinate I should say. You get a range of points all the way down. You have your point P. Mirror those points across through the axis. So mirror through the axis, take your distance out and mark it back using your compass. And once you have all your points mirrored to the left side, you're ready to freehand in the full curve. Now that's to be completed by yourself there. That's page 86 done. I'm going to take that off, moving on to page 87. And here on page 87 we have moved on to hyperbolas. So for the given hyperbolas we're looking at tangents this time. And the first question there, they're saying use a method that's common to all conics. So first off, we have a method common that will work for all conics in a given scenario, and then we're going to have one that's specific to the hyperbola here as it's shown. So if you're just given one branch of the hyperbola only, we might have to know the method common to all conics. If you're given both branches and you don't have a directrix like we have here, then you'd need to know your second method. The first method that's common to all conics is to join the point to the focal point, and using your sliding set squares, run off at 90 degrees from the focal point. And where you go off 90 degrees and hit the directrix, that will give you a point on the tangent. So join point P to the focal point and then project off at 90 degrees to hit the directrix line DD1. That's the same, we've practiced that already for the other two conics, for ellipse and for parabola. Moving on to our second method. And in our second method here we're going to be, we have both focal points, both branches, but we don't have any directrix line. So we think back to an ellipse, I suppose, back to junior cert. In junior cert, if you were drawing an ellipse and if you were asked to find a tangent, well, the first thing you do is you join the focal points to the point on the curve. Now you keep going through, but for now we'll just join to the point on the curve here. And now we'll just bisect an angle, just like we would have at junior cert. So I'll bisect the angle there between the two red lines by setting any random size on my compass, and by striking on a second time on those points. And that little construction there gets me a point on the tangent. It touches exactly on point P. So joining the point P to the focal points and bisecting the angle. That is the method that is just associated only with, let's say, hyperbola, but it's quite similar in ellipse, I suppose. Moving on to our next page. So that is page 87. Two quick examples there complete. And I did mean to mention there when I was on this page, and I just added in now, if we did extend one of those through, and if we looked at the inside angle here, if we looked at that angle instead, so one extended through, and if we bisected that angle, so to bisect that angle there, you would then have a normal. So the tangent is by bisecting one set of angles, and this guy here is the normal, or the line that's 90 degrees to the tangent at a specific point. Forgot to mention that one when I was crossing. On this next page we're going to be taking a look at one of these examples. Let's just do the second one here on finding tangents to one of the branches of the hyperbola here from point P2. The method is to open your compass from P2 up to the focal point. And swing. And then take the transverse axis distance here distance between the vertices, and spin from the second focal point. That point right here will join on to the focal and will extend through, giving you, I didn't draw there for some reason, extending from the focal point through the point where the two curves cross and through to hit, gives me a point of contact right here, POC. So I join P2 to the POC and I get my tangent. Just one of those things you have to learn off. There's my tangent. Take that page off, that's number 88, and I'll be moving on to 89 next. Now here on page 89, this will be a pretty quick stop again. No need to stick on the page. I'll just hold it there so it doesn't slide off my board. Here on page 89, we're just looking at a little bit of the theory behind the hyperbola, double hyperbola. So for a double hyperbola, the distance from a focal point to a point minus the distance to the other focal point should be equal to transverse axis. Bit of a mouthful there. We'll stop talking about it and start seeing it now. The distance from point to focal and the second point to focal. Sorry, point to the second focal. So back in junior searches you've seen that if this was an ellipse, for example, the combined distance was equal to the major. And now for leaving certain, for this particular question and this style of question here on the double hyperbola, what you'll find is take away one focal distance from the other and the distance you have remaining here. So take the short focal, take this guy, call that distance 1, and subtract it from the long distance. So subtract the distance 1 there, and the remaining distance you are left with is always going to be exactly equal to the transverse axis, which is the distance there between the two vertices. So that's just one thing for you to remember. So that's going to be equal to the transverse axis. And that is here. Now you're going to need to know that for different problems that will come up. Let's just see that once more, see it in action one more time. The focal distance is down to A, and there. And if I subtract one focal distance from the other, the space remains should be exactly equal to the transverse axis, which it is again. So that's, as I said, one thing you need to remember. Take whatever notes you need to take down here, but make sure you're familiar with that. It's a very, very common and obvious type of question that could be put on there, where they'll give you a very limited amount of information, such as 2 focal points and a point on one curve. No curves given, and you might need to work from there. Or there's even harder variations that could come up than that. That's page 89. Moving on to page 90. And here on page 90 we'll get to put that bit of theory there from the last page. We'll put it into practice now, okay? And page 90, question 1. Given are the focal points of a double hyperbola. P is a point on one arm of the curve or one branch of the curve. Construct a portion of the double hyperbola. Right, so we might be looking at combining the theory we did in the last one with the compass method of constructing a hyperbola. Let's get going at this. So first thing I'm going to do is apply, actually, you know what, first thing I might do is even find the center, because we're going to need that center line of it eventually. So before this drawing gets busy, I'll just bisect the distance between the focal points and project that up. And at least now I have the center of the axis. Next, I'm going to use that bit of theory we just came across on the previous page, page 89. And the difference in the focal distances is going to be equal to the transverse axis. So there's my focal distances. I'm going to subtract one from the other. So subtract the short distance here from the long one. And what I'm left with is there. Right there is the distance between the two vertices. Still no good to me though, is it? Because I can't set a diameter equally through the center point. So I'm going to take that portion, I'll just actually mark it in a different colour. From the green arrow to the green arrow is the transverse axis. I'm going to bisect that. And don't get confused between the bisect that you already did and the new one you're just after doing right now. And what I've just done is given me the center point of the transverse axis distance. So that's subtracting one focal distance from the second, using the remaining space, splitting it in half, and set your radius. And just check it there, make sure you've done this properly. And that's my radius. That transverse axis can then be marked. You can mark it as a full auxiliary circle if you want. But what the only thing it actually does for us and what it gets for us is a vertex and a vertex. Now I'll call that focal point 1, vertex 1, vertex 2, focal 2. To draw the hyperbola, we're going to map out some points on the axis, just like we did in the previous class. And I'll just go 10, 20, 30 and 40 here, and I'll go 10, 20, 30 and 40 to the left. That gives me 4 points in the left branch, 4 points in the right branch. I'm going to number those points, well, just because I always do it, and I'll just call that 1, 2, 3 and 4 here on the right hand side, and 5, 6, 7 and 8 here on the left hand side. Now you can number them whatever way you want, and don't forget we are going vertex to point from focus. So there's our first ones, and it's vertex to the same point from the focus. While I'm here, vertex to point 2 from focus. Vertex to 2 from focus. Vertex to 3 from focus. And it's all repetition of this method, and I'm going to have to do the same thing then all over again at the left hand side. I'm going to mark that point now before I lose it, just there above the point of contact, or that point that's given on the curve, which looks good, looks like it will flow through nicely. Finally, vertex to 4 and focus. And that gives me all of the necessary points in the curve. I can draw this freehand curve in, hit the vertex and come back down this side here. Same construction on the left. Vertex to point from focus. I'll stop saying it now, I promise. I'm going to do them all, just do all 4 when I'm here. 5, 6, 7 and 8. That gets me the remaining points here on the left hand side. So 1, 2, 3, 4, and the vertex is 5. And there, that is all my points, right and left, and they need to be joined up with the freehand curves. Make sure you don't come into a point at the vertex at either side. And I'm just doing it very quickly now. You don't need to see me freehanding in. That's my excuse now for having poor curves. You don't need to see really good ones from me. That's going to take too long. That's that one done. There's another one here, similar sort of a setup as the previous one there. Below is the focus of one arm of a double hyperbola. Point on the arm is 34 mil below the axis and 36 mil from the focal point. We'll use those measurements in a minute and we'll plot out that exact point. So 34 below the axis. Just start with a random position there. Measure down 34. I'm guessing that's the main axis through the object. 34 below the axis is done there. Point on the arm is 34 below the axis. 36 mil from the focal point. So taking my compass and setting 36 mil from the focal point. But this could be an interesting one now because it could be out to the front. What's the most realistic one? It'd be here or here. Hard to know. Hard to know which one that's going to be. So with a hyperbola, it's probably not going to be out there. That's a very long distance out. I'm guessing the shape of a hyperbola, it's going to be this back one here. I'm going to go with that and see. Now it's a little bit loose there. We're not quite sure what that might be. So if we just look at the shape of the previous hyperbola, maybe that's a realistic one. Possibly could be this one as well, but it would be a much broader curve. I'm going to go with this back one and see. So 34 mil from a point on the arm is 34 below the axis, and it's 36 mil from the focal point. I'll go with this and see how it goes. What else do we know? The transverse axis is 50. So the transverse axis is 50. We can use that now. Usually if we had one focal distance to a point and we had the second focal distance, the difference between them would be 50 mil. That means that the distance from the point to the second focal is this orange line plus 50. If I just take the orange line that was there and I extend it on, and the transverse axis is 50, I've just added 50 on there as a direct distance. I know that the total distance here, which is one focal distance plus 50, should get me to the other focal point. Okay, that means just drop it in there, hopefully to help the understanding. If I was given the question in the more basic way like we were in the previous examples, I'd have done that, subtracting the focal distances, and I should be left with a distance here of 50, which I am. So I added the 50 on, made that my P to F2 distance, and marked it across to F2. Taking a look at this now, maybe I could have used the outside point and made this a bit bigger. It's fine, it'll work just fine. Where do we go then? So the transverse axis is 50, construct a portion. I'm going to take the compass and just bisect the distance between the focal points there. That gets me the centre of my drawing. And 50 is the transverse axis, so I can just measure 25 mil out. 25 mil there, that will get me to one vertex. And from that centre point, I just draw my transverse axis and my auxiliary circle there. that gets me V2, and it gets me V1. I hope that makes sense now. So working backwards from what we would have usually been given before, all I had was one focal point, 1 point on the curve, and I was told the transverse axis was 50, so I add that 50 on to give me the combined distance to one focal, plus the transverse is the distance to the second focal. And 50 then being the transverse means if I find the center of the focals right there, bisect, I can swing a radius 25, giving me a total distance from vertex to vertex of 50. Construct a portion of both arms, and look, we're back to the same thing here where I can just map out my points 10, 20, 30, 40, maybe 50 even in this case for this side, and I just have space maybe for 40 mil on this side. Setting your compass, I'll just do 2 or 3 points and leave it at that. So vertex to point from focus, and you can do them all at the same time if you are confident in doing so. Opposite vertex. So if you're happy to do so, as I said, you can plot out a number of points at the same time. I'm only highlighting because I just wanted to show up in the video. I wouldn't usually do this if I was just doing a drawing myself. But from here, you'll obviously plot out your points on the opposite side as well. At 10mm intervals, it gives us quite a good number of points to work with to help with freehanding in this curve. Oh, very, very rough example of that. Page 90, that is complete. We're going to move on now to page 91. For yourself, of course, you're going to finish this curve, plot out this curve using your compass method, and finish drawing the 2 curves. Okay, so page 91. And on this page, we'll see we're given a sample of a question here again, based on some of the same theory. So we're going to be using a lot of our understanding of the material I've just covered earlier throughout this video to solve this question here. Now, what are we given? So there's our setup. AB and a point on the axis, or is it the focal point? A, B, and I suppose the focal point so being there. That's what's given. The given points A and B are points on a double hyperbola as shown below. So A is on one branch, B is on the other, and we have our focal point out here. This time, for the first time, this is not the axis. The axis is up here at an angle. So we have one focal, we'll have a vertex, and a second focal. Given that the transverse axis is 60. So transverse axis equals 60. And if you feel like it, just drop down distance from vertex to vertex. Construct a portion of the double hyperbola. Now, what do we do here? I'm going to think just like I did there with the last question. The distance from the focal point to a point. And if you want to, do it here as well. I'll just colour code it, do it here as well. The second focal point, I'll actually find it kind of correctly here. That would be the second focal point there. That would be F2, and the distance down here, well, it's going to be F to B plus 60. Right, so the distance from F to B plus 60 mil is going to give me the distance of all the way over to this focal, because as you know, if I subtract this short focal distance from the long one, I'll be left with 60 mil. What I'll do is this. I'll take the distance from F to B, I'll extend on, I'll just go this way now. I'll add on 60 mil, which is the transverse. And I'll set my compass to the combined. Now that is the distance from one focal point to the point plus the transverse axis of 60, and I'm setting that from B out to the focal. So the other focal point is out there someplace. I have a second point that I haven't yet used, so what I'll do this time, I'd say the distance from F to A minus that focal distance there is 60. So there should be 60 mil between here and here. What does that look like on our question? Distance from F to A. And only for having this sketch, I would not be able to, I might not be able to fully imagine what's happening here. This sketch is really helpful. If I'll subtract the shorter focal distance from the longer one, I should be left with 60 on this side here. So I'm going to measure across by 60 from the focal point to there. And I'm going to swing the distance A to this guy up. That's my second focal point. So I've used both pieces of information that they have given to construct that second focal point. I'll come back and add some more notes there. It's very important that this actually makes sense now. There's no point in copying a method if you don't get why it works and how we use the bit of theory from earlier. That is my axis. I have my axis drawn. I have my two focal points found. Just label that second focal point right there. F2 is there and F1 is here going through the axis. What did I use here? How did this work? That was my second focal distance. And that was my second focal distance. And once again, like a page that we did much earlier, if I took the distance from point B to one focal point, the shorter one, and subtract it from the longer one, the remaining distance out here to the end, that orange line that remains out from that point out to the end. In other words, the difference between the focal distances by subtracting the short one from the long one is the transverse, is 60. Very same goes for in green. From point A I joined to the two focal points, and if I take the short distance and subtract it from the long distance, the remaining distance here is 60, the transverse axis again. So that's how I do it. And if you don't get that, you need to really study this method. You need to look back maybe on some of the other examples that we did. We're going to bisect the distance between F1 and F2, same as always. I hope I'm not quite large for this now. Keep it out of the way of the other constructions. So there's my bisect, passing those points and hitting right there, and it's 60, so I'm going to measure 30 on one side. I'm going to draw the auxiliary circle there that goes in between, and that's going to hit both vertices, V2, V1. Finally, pass out your points again. So I'm going to just do 10, 20, that's roughly about 30, and I'll go 10, 20, 30, 40 and 50 outside that. Do the same here, drop in your, it's about 30 mil between, that's a bit more, but just roughly 10, 20, and we'll do 50 mil to this side. Same as before, compass method. Vertex to point from focus. Now that one's not going to work actually. Vertex to the next point from the focus. Still not going to work. Vertex Oh yeah, of course, what am I doing? I'm thinking of eccentricity there. We'll start off, points are all outside the focal, so point 1 is outside the focal, of course. 3, 4 and 5 there outside the focal. So vertex, ignore them inside ones. That's a habit there from doing the eccentricity method, where we would have the line of eccentricity, axis directrix, line of eccentricity, lattice line, vertex. There's such a habit of doing these and plotting maybe 1 or 2 points inside and then the remaining points outside. That's not the same here, of course. So starting from outside the focus, the vertex to point 1 from focus, and that'll get us points between the vertex and focus. Vertex to 2 from focus, vertex to 3. As I said in previous examples, if you're more comfortable in just doing these one at a time, then, or one pair of points at a time, then do so. I just like to plot them all out. It's more efficient, it's faster. But it's only more efficient if you get it right. Second vertex to 1 from the focus. I need to make them longer. Yeah, I didn't go long enough up here on this side. I'll get back to them in a minute. Vertex to 3. To 4. And finally to 5. Let's get back to this side, so it's going to be from the focus. Once all that is done, just going to catch point B here on the way. Of course, I should be switching over to my pencil for this job. There's one branch. And the second. Remember my points out here again. Vertex to 1. Actually, what did I do last time? I did the larger one first. Vertex to 1. And focus. And I'll go this time. That's my 5th point, and it was interesting to see how accurate or otherwise you are by the time you get out to these last points here. That's not looking too bad there. So it's going to go from A through 5, 4, 3, 2, 1, the vertex, back up to 1, 2, 3, 4 and 5 here. I'm actually going to just take the tape off this page, move it around. That'll help me in the free hand. there we have it. 2 branches of the hyperbola using the exact method and the exact theory that we had in previous questions. Much harder question of course this time, but subtracting the focal distances to find the transverse axis. That's page 91. That's the last one I'm going to do for this video. So I'm going to do one more video on this topic. The topic still has to, there's still a little bit more to go through in terms of establishing conjugate axis, asymptotes and direct recess from here. Once you get this far, you have a few more bits you need to learn how to put in. First, then there is all types of your tangents, your centre of curvature and evolute towards the end of the topic. Thanks very much for tuning in, and I hope you learned something from the video.